Hey, good morning, Pirates. Wanted to do a real quick discussion. Make sure you got the big ideas from our surface tension penny lab. When you click on this assignment, you'll drag the PDF to your desktop so that you can work on it using the Google tools, or excuse me, the preview tools to annotate a PDF. You should start by doing the background information, which is actually at the end, and then work through the actual lab. If you are virtual, there will be a data sheet that the students put their data on that are in person, and you're going to use the in-person data. So pick 4 students for your 4 trials and use their data. So when you do that, when you click on that PDF, you get this document. You'll notice it says after completing the background information at the end, read and work through the lab to complete. So we're going to go to the background information at the end, and here's what you actually have. So water molecules are blank to other water molecules, and you're going to use this information right here that I have highlighted to fill that in. And so when you are done, you will have these 2 statements. Water molecules are attracted to other water molecules. The oxygen end of water has a negative charge and the hydrogen end has a positive charge. Hydrogens of one water molecule are attracted to the oxygen from the other water molecules. This attractive force is what gives water its cohesive properties. Surface tension is the name we give to the cohesion of water at the surface of a body of water. And so it's like the molecules that are not only touching other water molecules but touching something else. And cohesion of water molecules forms a surface film or skin. Some substances may reduce the cohesive force of water, which will reduce the strength of the surface skin of the water. And so cohesion can also be found in other substances. Right now we're focusing on water. Super important as we move into biology next year that you kind of have an understanding of cohesion and surface tension. Okay, so if you are in class, you're going to follow these procedures to get number of drops on a penny and then average. If you are a virtual student, you're going to click on this link right here to student data page, which looks like this. And you can see all of the students that I have in person. Give it a minute to load. Have shared their results and their averages. And so you can see all of the number of drops on a clean penny were higher than the number of drops on a soap-coated penny. You'll pick 4 students. So if I were to pick these 4, these would be my 4 drops on a clean penny. These would be my 4 drops on a soap-coated penny. And then I would average those in my data table as I complete my data. And then you'll do that again for 4 different classmates, identifying who they are and so forth. So you should have overwhelming evidence that adding soap to the penny reduces the surface tension on the penny. So let's talk about the analysis. In this study, our independent variable is the coating on the penny. We have a clean penny for our first set of data. That is our control group. And then we have a penny we dip in soap to see if soap affects the surface tension of water. And that's the surface tension of water is our dependent variable. So the coating, clean versus soapy. Clean would be our control group. The soapy penny would be our test group if we were kind of designing a study. Now I'd ask you to explain how soap affects the surface tension. Soap reduces the number of drops on water that can go on a penny. The surface tension of water is reduced with the soap. In other words, the force of attraction between water molecules is weakened by the soap. And so that's an important connection you need to make as we start to think about our third part of our unit objective right now. And then now that you have an idea about how soap affects surface tension, what are some other questions you could use? So you could pick another substance. How does vinegar affect the surface tension of water? And dip a penny in vinegar. And so you could pick any substance here and test its effect on the surface tension of water. Again, that would be testing water, continuing to test the surface tension of water. We could also use the same design of the study to test other substances. When compared, which substances will have greater surface tension, and use the drops on a coin of those substances. Obviously, those substances would have to be liquids at room temperatures in order for us to test them. Hope this clarifies. Do you have any big questions? Please shoot me an email. Have a good afternoon.